The third type of partial fraction decomposition that we're going to look at is when we have a factor in the denominator that is not linear and it doesn't factor out. So if we look at this fraction, we've got the negative 2x squared plus x plus 11 in the numerator. We've got one linear factor of x plus 1 in the denominator, but that x squared plus x minus 4 is a quadratic, and unfortunately we can't factor that out. If we could factor it out, we could just have three linear factors. We could split it up into three fractions like we have with the other examples we've done. But where that second factor doesn't break apart into linear factors, we're going to have to treat this one a little bit differently when we split it up into the fractions. So I'm going to start out with this original fraction, so the negative 2x squared plus x plus 11 divided by the x plus 1 times x squared plus x minus 4. And I'm going to set that equal to, I still have two fractions that I'm going to be working with. The first fraction is going to have the x plus 1 in the denominator. The second one gets the x squared plus x minus 4 in the denominator. And this first fraction is going to act like normal, where we have just a single variable up top. But since the second one is not a linear factor, it's a quadratic, we need to put multiple variables up top so that we have a linear factor. Because the reality is this is potentially two factors that have already been combined together, and we might have more things happening up in the numerator than just a single variable. So we're going to account for that by putting a bx plus c up in that numerator. Now once we do that, we can continue just like we would with any of the others and multiply through by that common denominator that we had in the original fraction. And we do this in hopes of trying to clear out that denominator so that we don't have to worry about the fractions anymore. So when I multiply the fraction on the left side of the equation by both of those, that denominator completely divides out, and I'm just left with what was in the numerator. When I multiply the fraction with the a by both the x plus 1 and the x squared plus x minus 4, the x plus 1 is going to go away, but the other term is not. So I end up with a times x squared plus x minus 4. And then when I multiply the last fraction by those, I end up getting this bx plus c needing to be multiplied by the x plus 1. So now I can go ahead and distribute this out further. I end up getting, I still have the negative 2x squared plus x plus 11 over on the left side. But when I distribute, I have an ax squared plus ax minus 4a, and then plus, if I distribute these out, I get a bx squared plus bx plus cx and plus c on the very end. So now I need to group my common terms together to try to create my system of equations. So I've got my x squared term on the left, I have an x squared here, and I have an x squared here. So the first part of my system of equations, I could say, is a plus b, the two coefficients of the x squared, need to add up to the coefficient on the left side, which was a negative 2. Secondly, I've got an x on the left side, an ax, a bx, and a cx on the right side. So I've got 1a plus 1b plus 1c should equal a positive 1, because that's the coefficient on my x right here. And then for that third equation, any term that doesn't have an x, I've got negative 4a. I have a positive c, and those need to add up to 11. So those were the last two terms that we hadn't done anything with. Now, what I probably want to do with this one is I'm going to take the top equation and solve it for B. I'm going to take the bottom equation and solve it for C, and I'm going to plug both of those into the middle equation. So if I rewrite this top equation, that's going to be B equals -2 minus A. The bottom equation would be C equals 11 plus 4A. And then I'm going to substitute that in here, substitute that in here into this middle equation. That way, my middle equation only has A's in it. So I've got A, and then plus the B values, so that gives me -2 minus A, and then plus the C value, so that's plus 11 plus 4A. All of that should add up to 1. So if I simplify that all down, this A and this A are going to subtract out. I get -2 plus 11 is a positive 9, plus 4A is equal to a positive 1. And that means 4A is going to equal a -8 if I subtract out the 9. And then divide that off, I get A equals a -2. So that's one value that I need to work with. So I'm going to take that and plug it back up into both my B and A equations up here. So this one, -2 minus a -2, that means my B value is going to equal 0. And then my C value, I'm going to get 11 minus 8, so C is equal to 3. So those are my two other values that I have. So then it looks like one of our variables canceled out. We don't have a B, but we do have a C and an A to plug back into those original fractions up here. So the x plus 1 had the A on top of it. So I've got a -2 over x plus 1, and then plus my C value was 3. So 3 divided by the x squared plus x minus 4. That would be the partial fraction decomposition of the original that we had up here with the -2x squared starting out as the numerator. And notice that the b, we didn't have that term as part of our answer, and that's okay. But we still needed to account for it just in case that term existed as part of our solution.